In this tutorial we will learn how to make a fully 3D clock using what we've already learned from our previous tutorials. While it won't cover absolutely everything we've learned, it will cover the vast majority of it. Plus we'll also introduce you to a few new commands and a few new concepts. So the special thing about this clock is as I say, it's fully 3D, so if I press the P mode, as you can see, we have full control over a perspective mode. So we can control zooming in and zooming out. We can rotate it around the face. We can increase the height of the camera. So basically we can manipulate the display and put it at any angle or view we wish. Obviously the clock is in real time. You've got the time and date in the corner, so you can see the hand is corresponding quite nicely, and once it's done you'll have a far better knowledge of how to implement 3D technologies, how to process data, and the advantages of functions and keeping tidy source code. So I'll see you back in the IDE. Before we start learning how to program this, I would like to show you one of the reasons that I preach good housekeeping so much via the use of functions. This is a relatively short program. It's only about 150 lines, probably about 120 if I take out all the spaces. But if you look down here, there's an awful lot of code to have to go through to find something, and I mean, this is the beginning of the program before we even get to our main loop. And then we got our main loop here, which has all the real-time stuff going through it. So as you can see, there's an awful lot to actually go through. However, if I show it to you in a neater form, well, we can't actually get away from the initial starting variables. They're quite easy to go through. And now we've reduced the make, so all the pre-start sequence down to these lines here. So you can easily see what's going on, set in perspective mode, make face numbers, make the clock face, then it's creating a set of clock hands, so very easy to read, and then the main do loop has been basically reduced down to 4 lines. So this makes it a lot easier to see the flow of the program, and so you can work out exactly what's going on and what you need to adjust if you need to make any changes. Of course, everything's been put in functions, which are equally easy to see. If we fold all our functions together, we've basically reduced them down to these lines. So anytime you wish to change one of the commands you've made, all you've got to do is click on that. You've got the source code there, and when you're done with it, you can hide it away. You just go back to your main source code project and you can change the command. So basically we've reduced about 165 lines down to just 53 in the main program, and I could reduce them down further by using ghost subs and extra things, but I personally prefer to keep the initial startup variables at the beginning. It's good common practice, because they're the first things that need to be set up in any program. I have in the past used ghost sub to set all these up, but it's caused problems now and then, so it's a good idea just to keep them all at the beginning anyway. But once you actually get to the main program itself, it's reduced down to remarkably few lines. You got line 24 and to line 53 for the entire program. And of course you go back to functions and everything's been reduced down nicely. So I say it's much easier to manage and work through your program in this state than the mess I showed you before. But rather than simply showing you the code that's already been pre-written, I'm going to go through the code with you line by line, and we'll see how everything's formed. But to start off with, we'll look at the flow of the program and take it from there. So I'm going to start off by creating a new project. So we click on File and New Project, and give the project name, well, a name. So DarkClock, click on OK, and this will then produce all the files we need. I will be using functions in this, and I'll be keeping them in a separate file. So I'm going to click on Files now, click on Add New, and we're going to create another source code file called functions, and this will serve as our location for the functions. Now we're going to go back to the main program, and we're basically going to start off by initializing the 3D environment. So sync on, sync rate 30, backdrop on, color backdrop, I really want to set it as black, 0, 0, 0, and set the auto cam off. Whoops, auto cam off. And now we actually need to start building the clock face itself. But in order to get the 12 to 1 around the edge of the clock face that you saw earlier, we actually need to create textures for that specifically before we start drawing our 3D objects. I'll explain that when I actually go into writing the function itself. But for now, I know I'm going to do this, so I'm going to create a function here called make face numbers. And when it comes to writing that when it comes to writing that function, I now know what the name is. So the next thing I need is to draw the clock face. So I'm just going to call that clock face. And of course the final thing we need to do is make clock hands. So make clock hands. Whoops. And once that's done, that's all the objects and textures we need created for the program itself. And then we're going to go into the main do loop. So do sync loop and end. And we basically only need to do two things. I will be writing in the perspective commands later, but initially all we're going to do is build the clock and set up the main display, and then we're going to worry about actually tweaking the camera and dealing with that. So what I basically need to do is move clock hands. So move hands will basically be the function that moves the clock hands for us, and then we want write time and date. So we've got another function, write time and date, and that's basically all we need to do with our program. It's the sequence of things we need to complete is now written. So what we need to do now is go back and actually write the functions themselves. But before I do that, of course, we also need to set up our variables and types. So I'm going to insert those at the very beginning of the program, which is where they should be. And we're going to create a new type. And we're going to create this type as for the hands, or the hand objects we create with make clock hands. So type hand type, and then we're going to type in hour as integer, min as integer, and sec as integer, and end type. So we've now created our type, and of course we now need to assign that type to a variable. So global hand as hand type. The next thing we also need to do, of course, is actually assign object names to the hands so we know what to refer to them as. As they would be the only objects we're actually controlling within the main and do loop, we have to have a record of the hand numbers. So I'm going to create 3 in here, hand.sec, whoops, hand.min and hand.hour, and of course we need to assign numbers to those objects. Now when I create a lot of objects in a project, we're dealing with about 59 objects or 60 objects for the main indentations of the clock face. We have a central object for the middle of the clock face. This will be a sphere. Plus we got the hands moving around the edges, and of course we got the 12 planes we're going to be making around the clock face as well. So that's an awful lot of objects to keep track of. So what I'm actually going to do is name the objects dynamically. And I'm going to do this by using another function, which again I'll show you how to write in a moment. But because I've already planned this out and I know what the source code's going to be, I can now type in hand_sec equals free object ID, hand.min equals free object ID, and hand.hour equals free object ID. Again, this is a function I've written many times in the past. It helps automate the creation of objects without me having to remember that the first object 1 is going to be the sphere in the middle, then it's going to be 2 to 61 is going to be the indentations around the clock face. Then I have to remember that the next set of objects are going to be another 12, so I've got to take the object. So as you see, it can be quite difficult keeping in mind, especially when you're dealing with very big programs dealing with a lot of 3D objects. So it's easier just to automate this process, so the computer will work out the next free available object ID, pass it back to the program so you don't have to remember it, and all you then have to do is assign logical names to these objects such as hand.sec, hand.min, hand.hour, and that way whenever you want to move a specific object you refer to it by name rather than some obscure number. Because the objects won't have been created between these points here, what I basically need to do is offset them by 1 and 2 places. So it will come up with the last free object, then it will come up with the last free object plus 1 because that's going to be created there. Then another one's going to be created, another one's going to be created. So we need to increase that value by 2, otherwise the program will basically be trying to assign the same number to each object. And of course, now that I know what the object hands are going to, what the clock face hands are actually going to be referred to, I can also type it into the move hands function. So move hands, hand.sec, hand.min, and hand.hour. And this will then pass the object numbers assigned to these particular objects through to our move hands function. And that's basically it. That's all we need for the main program loop. So now of course we've actually got to go and create our functions. So to do that we double click on functions, And the first one I started off with was make face numbers. So we have to now instruct the program how to create the textures using that function. So I'm going to create the functions here and make face numbers. No parameters need to be passed. End function. We're not passing any numbers back, so now we just need to type in the body of the code. So I'm going to start off by using our 2D text commands to actually set the font. So set text font, and we're going to set it to Arial. Then we want to adjust the text size, so set text size, to 20, and set text to bold. Then we need to create a loop for x equals 1 to 12. The reason I'm not using zeros here is because you cannot assign an image number of 0. You can only assign between 1 and infinity. So next x. And what we're going to do now is actually create the text create the text on the screen. So text 50, 50, string, and of course we need to get the number of the clock. So the first number we create will be 1. So this will now print the number 1 to the screen. And this is a new command that you haven't come across before. What this allows you to do is basically grab any visual information that's been displayed on the screen or been created in the scene and store it as an image. And we do that by typing in get image, and we need to type in the image number that the image we take is going to be assigned to. So that's going to be x. And then we need to set the coordinates making a box around the area that we need to grab the image from. So I've pre-experimented with this. I found the best coordinates already, so I'll type in them now. So we'll now grab the image between 40 and 40. So y1 is going to be 40. Sorry, x1 is going to be 40, then y1 is going to be 40, then x2 is going to be 70, and then y2 is going to be 70 as well. So that basically assigns a nice box around the characters we create. The next thing we need to do is, after the image has been grabbed, we need to clear the screen. Otherwise, all we're going to be doing is getting a blurred image, because we're not running the sync command. We don't actually want the visual information shown to the user. This will be done in the background, so no one will notice. So that's basically our make face numbers function. So now that's been written, we can fold that away. Obviously, in a normal development process, I will be viewing the textures that I've already made by pasting to the screen or an object. But I don't need to do that in this case. Sometimes the fold function doesn't work very well, so if it does create problems, just leave it open. Now we're going to refer back to our other program, and the next thing we need to do is actually create the clock face. We created the media we needed for textures to text the clock face. Now we actually need to make the clock face itself. So we return back to functions. So I'm going to type in function clock face, and we're going to create our 3D clock face using this function here. Again, we don't need to pass anything back to the program, so end function. So I already know I'm going to be creating my free object ID command, which I'll probably do at the end of the program. So I can set temp to equal free object ID, because this is a function I've written so often and I include it in almost all my programs. I tend to just sort of copy it and put it in at the end. So, but you'll learn how free object works in a moment. So next I need to set count at 0, and I'll explain this again in a moment. And then we're going to create a loop. So for x equals temp to the number of objects we need to create. So because 0 is counted as a number in this case, we only need to increase it by 59. So whatever number it lands on will be an object slot, and then we count up 59 units from that. So temp to temp add 59, which will automate it for us quite nicely. And now we need to actually make our objects. So make object cube, give it the object ID of x and the object size of 1. Now I need to turn the object right, give it the object ID, and this is where a bit of mathematics is going to come in. Basically each indentation on the screen is going to be 6 degrees because each turn of the clock is approximately 6. That's 360 degrees divided by 60 is 6. But rather than having to work that out in our head, all I have to actually do is put the bracket here, take 360, divide it by 60 itself, and that will give us the number correctly. So I don't have to rely on my own faulty mathematics just in case I'm wrong. But of course we also need to adjust the amount we turn right by however many times an indentation has been created. So if an indentation has only been created once, then that's going to be at the central point, that's going to be 0. So basically if I take count and I times it by that, then 0 times anything is going to be 0. So in fact it's not going to move the object, so it's not going to turn the object right at all. So this would now just move the object forward when I type in move object x, 120. Again, I've experimented with this in a separate program, so I know all the positions and the distances I need to set quite nicely. And of course after that we need to increase the value of count. So inc count and then next x. Now when count goes to 1, it will then move the object right by 6 degrees, because 1 times 6 is going to be 6. And if it counts to 2, then 2 times 6 is going to be 12, and etc. It will just keep going up 6 degrees every time the count number increases. But I've made a bit of a mistake here. I actually wanted to put a central object in the middle of the clock face, and this is one of the reasons that using the free object method is so useful, is because if I do make a mistake I can put something before it. I don't have to reassign all my object numbers. So temp equals free object ID, and now I'm going to make an object sphere. So make object sphere, give it the temp ID and the number 10 for the size, and I want to also position my camera. This is one of the ways I've created the initial view mode, is to place the camera up the y-axis by 240 units. So to do that I'm going to type in position camera 0, 240, 0, but of course the camera will still be looking straight ahead. So I actually want it to look directly at the object I've just created, and with AutoCam off, that isn't automatic anymore, so I can set it up manually. So point camera, and then we're going to give it the object positions of the objects we've just created. So object position X. Now I know this is the first object I've created, so I know it's 1, but were I to realise I need to put anything before it, then it still needs to be set to temp. So if I created another object before this one later on, it won't crash the program. So we're going to set it to look at object position X and the temp ID we've already gained from our function. So object position Y, again temp, and object position Z, again temp. And there we go, we've created our central object. We've positioned our camera and it's now pointing at it. So this is one of the reasons that this free object trick is going to be very useful. Next, of course, we've made 60 indentations around the clock face. But if you look at a normal clock, then the numbers 1 to 12 normally have a long line to mark where it is. So we're going to do the same now by increasing the size of every 5th indentation we make. I could simply create a new bigger object and overlay at the top, but that's wasting polygons. So instead what we're going to do is we're going to resize every 5th indentation. And because we're working with the previous set of objects here, we're going to carry on with the current temp. And I'm going to start off with the same loop for x equals temp to temp add 59, and then we're going to scale the object, but we only want every 5th object scaled, so I'm also going to use a step command. So step 5, and this basically means that every 5th number in the sequence between temp and temp add 59 will be the object that's resized. So I'll do that now and type in scale object x, and I want to scale it by 250 by 100 by 750. Again, I've pre-experimented with these and I've found that this is the look I want. So I also want to set the color to give it a more distinguished look over the other indentations. So color object ID of x, and then we set the color, and I want sort of a goldish orangey color. So RGB 255, comma 0, sorry no, comma 100, comma 0, and close bracket. And now I'll end the whoops, I just deleted that, didn't want to do that. Now that I've set that up, I basically want to end the loop again. So next x. And of course the next thing we need to create on the clock face is the textured planes that go around the edge of the clock. However, there's something you need to know about this before we start. In order to make our clock face, we're going to be using a combination of cubes, spheres and primitives. Now the sphere will go in the middle of the clock, and that will basically be the center point by which our hands move around. The boxes or cubes will make up each indentation around the clock face. Then we'll resize every 5th indentation to make sort of 12 o'clock, 1 o'clock, 2 o'clock, etc. And finally we're going to create a set of planes that we will apply a texture to. So the thing to remember, however, when mixing main primitives such as boxes, spheres, etc. and planes, is that planes actually work in the exact opposite. So if you type in turn right, then you need, or for an object such as a cube, you need to type in turn left for a plane. The alternative is that you can reverse the direction of the plane. So if you move a box forward by 120 units and you want to put the plane above that box as we do now, we actually need to move the plane in negative 135 in order to get it above there. So I'll just show you a quick demonstration. As you can see, our boxes are being created in a clockwise direction. This is using the right command. And then we're creating the indentations around the clock face. So every fifth box is being resized, and then we've got the planes which start in the same place but they go in the opposite direction. So this is why we're actually counting backwards in our textures, is because of this orientation problem with planes. So once you know that, and once you know all you got to do is basically reverse your thinking for planes, then it's easy to combat. But it can create a lot of problems for new users, especially when they're mixing the two technologies together, because the boxes will turn clockwise and the planes will turn anti-clockwise, despite using the turn right command on both of them. Had I also not reversed the position to negative 135 rather than positive 135, we would have started here at 6 and then worked our way around. So we're going negative in order to start at 12 in the correct position and then create the planes around the clock face. So now that you know about the problem with planes, we can compensate for it. So in the same way for the rest of the, in the same way as we have so far, we're going to assign temp to the free object ID place. And now we're going to set count to equal 12, because when it comes to actually placing our textures onto each plane, because the order has been reversed, we actually want to go from 12 to then 11, 10, 9, 8, etc. Next we're going to create another loop. So for x equals temp to temp add 11, and now we're going to make an object plane for each loop. So make object plane, object ID, and 20 by 20 I found is a good size. And remember, now even though I'm typing turn object right, it will actually go anti-clockwise or in the left direction. So I'm going to use the same math as before. Count times 360 divided by 12, because we only need 12 placements around the clock face. Move object. Remember again, the orientation is reversed, so rather than moving in the 120 or 135 to put it above, we're actually going to move negative 135. And next, in order to make the object actually face us, at the moment it's facing towards the center, so we need to make it face upwards. So we're going to use the command pitch object up x comma, sorry, too many x's, x comma 90. And then finally we're going to texture the object. So texture object, object ID, and we're going to be using count here because we're going from 12 downwards, because when we created our textures we created them 1, 2, 3, 4, 5, 6. We wish to reverse that and assign 12 down to 1. And of course the final thing we need to do then is decrease the count value by 1. and next X. Remember, decrease doesn't actually need a value if you're only typing in one. If you're only decreasing it by 1, but if you want to decrease it by a fraction or another number such as 2, 3 or 5, then you basically need to type those number after a comma. But we don't need to do that here, so that's it basically. We have created our clock face. So what I really need to do now is test the clock face to make sure it's working. But before I can do that, I also have to write the free object function. So I'm going to do that now. So function free object ID, and we're going to be returning the object ID to the program, so end function, and we're going to call it object ID or object.id. And now what we're basically going to do is create a simple loop using the repeat and until, and we're basically going to count up the existing the objects already in existence, and when we find an object slot that hasn't been assigned to a number, that's the number we're going to return to the program. So we're going to start off with, at the beginning with object ID equaling 0. So we start off at the beginning, and then we're going to type in repeat and until ID equals 0, and between that loop there we need to type in inc object ID, and this will increase that value, and then we type in ID equals, now this is a new command, as I say, it basically checks an object ID to see whether or not the ID has been assigned to an object. So object exist, and we need to check the number that's going up, so object ID. We need to put the inc command before object ID because it needs to be 1. So you cannot get an object 0 assigned, you can only assign it from 1 upwards. So basically what will happen now is this cycle will continue until object ID equals 0. When it equals 0, it means the object typed in there isn't assigned. It doesn't have a slot. But if it comes back with 1, it basically means that yes, that object does exist. So very simple, very easy to use function there. That it's only about 5 lines of code, and it saves you from having to remember endless lists of model IDs and getting very confused, and then having to change everything if you need to insert anything before them. So now we've done that, we can actually test our program. So I'll go back to the main, and we'll disable all of these for now because we haven't written these, and we'll actually see how far we've gotten in our program. But before I do that, of course, I need to set up the window resolution. So we're going to set it to window mode, and now when I run the program we should get a picture of our clock face and numbers drawn. So there we go, so far we've managed to create our clock face. Now that we know our clock face is actually being drawn, I'm going to take the disable off these commands here, and we're going to actually make the clock hands. So go back to the functions, and we're now going to create the we're now going to create the command make clock hands, which you'll see listed there. And of course it's a good idea to remember which sequence these are in as well. So go back to functions, and we're going to create a new function now, make clock hands, and we need to assign 3 values here, so sec, comma, min, comma, hour. These will be temporary variables. And of course we need to end function, and we don't need to return a value back to the program. So now what I'm going to do is make a new object, make a box. So make object box, give it the ID of sec, which of course will be assigned via hands.sec, and I'm going to give it these parameters 2 by 2 by 128. So I'll basically make it 2 deep and 2 wide and 120 units long. And this will be our second hand, which is the smallest. I also want to set up the object color. So color object, and we choose a nice red. So sec, comma, RGB 255, 0, 0. And because the object will be placed at the screen along its central axis, we need to move the object forward by 60 units. So move object sec, comma, 60. And basically we need to do the same thing for the other 2 hands. So make object box min 3, 3, 100 is going to be shorter, but it's thicker. Color object, and I want to set this to blue, so obviously you can choose any color you like. Min, RGB 0, 0, 255. And now I need to move the object by 50 units. And make object box for the hour. Make it thicker again, 4 units by 4 units, but make it shorter, so by 80. And color the object. RGB, and we'll set it to white. And finally move object hour by 40. You notice that all I'm doing is moving it forward by half the amount, by half the size of the object, and this will then put its endpoint in the middle of the screen. So now we've created our hands, we can basically return to the main source code. And I just realised something I didn't type in. So I forgot to put the object number here and comma, and I forgot to put a comma here. Whoops. If I compiled it, it wouldn't have worked. And of course I also typed in make instead of move. So it's easy to make mistakes like that, especially when you're narrating and programming at the same time. So now those are taken care of, we can see the objects actually created. So I'm going to compile the program now to make sure they look all right. So as you can see, we've created an hour hand, a minute hand, and a second hand, and each one is thicker than the other. And that way they overlap quite nicely. So we're going to close the window again and return to our programming. So we're going to return to our main source code and see what needs to be done now. So basically we need to write 2 more, move hands and write time and date. And these of course are part of the main loop function. So we'll return to the program. And I will create a new function, but rather than making the move hands command, we actually have to break down time into individual elements down into seconds, mins and hours. Now we've already done this in one of our previous tutorials, so we'll do it again. We basically need to break down time, so I'm going to call it function break down time, and we need to assign it some kind of value. So and get, if you call previously in the 2D tutorial, I marked it as if you typed in hour, mins or space in as a string, then it would retrieve the relevant data. So we're going to do the same thing here. It's the same command it's the same function basically applied to this program, which shows the reusability of these functions. So if you have anything else in the future that needs to break down time in this way, then you can simply transfer this function into that program. So if get string equals hour, then output, and if you recall, we need to basically convert the get time string into a value while isolating certain characters of the string, and we do that first with the val command, which turns everything inside it into an integer value, and then left we'll get the first left characters of any string, and of course we need to actually get something from it, so we need to type in get time string and then the number of characters we need to grab. So this will basically convert everything into an integer, get the first two characters of the string, and then get the time string from the computer and input that. So we'll then type in end if. And this of course is a good way of making a function do several jobs by allowing it to select a variable and then choose what to do based on the variable selected. I could of course create a case statement and just have 1, 2 and 3, but if I have hour in string, then it means more to you when you program. So the next we have to do the same for mins. So get, if get equals min, so if get equals mins, then we'll basically trigger this if statement. So mins string, yes, we basically need to convert the first 5 characters of left string into sorry, we're trying to isolate the middle string numbers here, and we do that by grabbing the first 5 to start off with. So left, and because we're putting it into a string, so left equals get time, comma, the number of characters you want to grab from the string, which is 5, and then mins equals right, so we're getting the first 2 from the right hand side inwards now, so mins string, comma 2, and that's now isolated the first 2 center numbers of that string, because if you recall it was time colon mins colon then year colon, no sorry, it was hour colon minutes colon seconds. Sorry, I've been programming for and narrating for a fairly long time now. And of course finally we need to convert the output back into val. So output equals val, and we want to put mins in there. So just to re-summarize, because my explanation was quite poor then, we selected the min state. We select mins from get, so we know which of the pieces of time we actually want to get from the function. Then I isolate the first 5 strings, which would be, the time is currently 07:11, so that's 5 characters including the colon. Then I isolate the first 2 from the left going inwards, and that will give us the minutes, and then I convert the mins into an integer value which we can pass back to the program. Now the final one, of course, is hours, so this will be a nice easy one again. So if get string equals sex, output equals val, and we only need to go in right this time, so right, then we need to assign get time, get time even, comma, and we need to go 2 characters in from the left in order to isolate the seconds. So now we've got that and passed it to output. We basically end the if statement there, and of course we need to pass the output back into the program, and this will do it. So output. So any time now I call a command that goes mins equals break down time, and I type in mins, then basically it will return the mins output value to the function and then back to the program of the variable mins. So this will now break down time for us and allow us to actually move our hands accordingly. So now we've done that, we now need to actually move the hands, which is what all this was in aid of originally. So function move hands, and we wish to select one of several values again. So sec, comma, min, comma, hour, and this will basically allow us to take the input of the object numbers directly into the function. So first we start off, because this is updating all the hands at the same time, we're going to start off with sec, move object sec, and we're actually going to move it backwards minus 60, and this will put it to the original position we centered the object with. The reason I moved it forward the first time is because now every time this function is called, it will move the hand back 60 points, rotate it, then move it forward. It may seem a roundabout way of doing it, but because the user doesn't see the hand moving until we update the screen, we can get away with this simple maths, and it means we don't have to work out any complex Euler angles or math in order to do it. So we're simply going to move it backwards 60 units, rotate the object by however many degrees we need to rotate it by, and then move it forward. And while I have mentioned that we shouldn't really mix the Euler angles, I can get away with it for this because it prevents me from having to rotate the object backwards the same number of units I did last time and then applying the same effect. So I am going to mix in a Euler angle here with rotate object sec, and we want to rotate it along the y-axis. So 0. So yes, rotate object sec, that's the object number, 0 degrees, and we actually want to retrieve break down time, and we're going to get the number of seconds for the second object, or the second hand, and we're going to times that by 360 divided by 60, again because there's 60 seconds in a minute, and we then need to break down 360 degrees into 60 parts, so it's going to be 60 degrees apart, and we only need to rotate the y-axis to do this, and I'm finally going to finish off the z-axis being set to 0. So basically only rotate it along the y-axis. The alternative method to this, as I mentioned, will be making a record of the last turn. So if my last turn was turn 40 degrees or 6 degrees or 12 degrees or whatever, I would then have to then type in turn object left the same number of degrees and then reset the object again. You can do that, but this condenses it into one line. So move object sec, 60. So as I say, again, we've moved it backwards 60 units. We've turned the object along the y-axis to seconds times by the number of units, or the number of seconds on the clock, and then we simply move the object forward again. And of course, because the user isn't seeing all these changes automatically, we can then update the screen and get away with it. So a bit of visual trickery there. And of course we need to do the same thing more or less with mins. So move object min. Again, we need to move it back 50. Rotate object min 0, break down time. We want mins, and we want to times that by, again, 360 divided by 60, and we need to set the y-axis to Z. So it's basically exactly the same statement applied to a different object, and then we move the object forward again. So move object min, 50. Now of course we need to move the hour hand, so move object hour, oops, spelling mistake up there, and we need to move it backwards by 40 units. Then we're going to rotate object object hour, and we're going to rotate it again along the same axes. But the mathematics is going to be a little bit different this time, because I basically wish to add some subtle movement to the command as well. So we're going to start off with the basic break down time. There we go. Hour. So we're now getting the number of hours. We're of course going to times that by 360 degrees, and because we're only moving 12 places around the hands, around the clock face now, we need to move it by 12. So 0, 1, 2, 3, 4 will correspond to the correct indentation around the clock face. But if you look at our hands in clocks, they have some subtle movement between the number of minutes increase. Sorry, as the number of minutes increase, the hour hand gets closer to the next hour point. So you've got a degree of subtle variation. It's not just like minutes and seconds, where it's either 1 minute, 2 minute, 3 minute, or 4 minute, or seconds is 1 minute, 2 minute, 3 minute. No, you can get away with that quite happily with those two hands, but with hour you need a subtle gradient between sort of 12 and 1 o'clock, between 1 and 2 o'clock, etc. So we're going to do that by adding break down time mins, and I'm going to times mins itself by 0.5 and put a 0 after it. So basically we've moved our hour hand to the correct hour, be it 1 o'clock, 2 o'clock, 3 o'clock, whatever, and then we've added on mins itself. And because it's basically a 30-degree angle between 1 o'clock, 2 o'clock, 3 o'clock, etc. Mins is 60 seconds, so all I actually have to do is divide that by half, or times it by 0.5, which is the same thing. And we basically have a 30-degree angle. So rather than messing around with complex angles, we simply convert mins itself into half a degree per minute, and that way we get the subtle gradient of hour hand movement that we wouldn't otherwise have. So a little bit of a mathematical trick there to avoid getting into complex maths again. And then of course we're going to finalise this by moving the object hour hand by 40 units forward. And this is basically then created our hands, this will now update our hands around the clock face. So end function, and we don't need to pass a variable back to the program, so that should be that. But of course one of the easiest things to do while you're programming, again, is to miss out subtle things. So we'll quickly test that now. So I've gone back to the main program loop, and I'll enable the move hand statement. And when we compile the program, I suspect I've left everything out because I've been talking and typing at the same time. So I'll just run the program there and we'll see if it comes up with any errors. So yes, as I expected. I've been a bit vague, so right, we need to add in 2 brackets there. So something very simple to do, something very easy to miss, but luckily DarkBASIC Professional took us to the line that was causing problems. So we run the program again. And there's another one. And of course here I forgot to put an extra bracket around. So you see you've got 1 bracket there, another bracket there, 2 brackets in the middle, then they need to close with 2 brackets. So again, another very easy mistake to make, but the language points it out for us. And apparently this command is out of place. And that of course is because if you look up the program here, I've typed in end there instead of end if. So if you ever get a end function is out of place, the chances are you haven't closed one of your if statements correctly. Let's try again and hopefully it will work this time. So there we go. Despite a few minor setbacks, a few very easy typing mistakes that anyone can make, we've gone back, we've fixed those, and the program now works properly. So as you can see, rather than simply being at 7 o'clock, we've got a subtle gradient of movement for the hour hand between these 2 points. So close that now and go back to the program. And the final thing I need to do is add a digital and date timestamp to the program. So I'm going to do that now with function write time date. So function write time and date, and we're going to display text on the screen to do so. Text 10 comma 10 and get time. Because it's already a string, we don't need to convert it. And the second one for date, so 10 comma 30 comma get date even, and close that with brackets. And of course we need to end function. We don't need to return anything to the program, so again that's it. And now if we go back to our main source code and disable, or rather re-enable the command, we should have our first stage complete. So as you can see, despite a couple of minor setbacks, we've learned that planes actually go around in the other direction. You have to reverse their orientation and movement. However, primitives will go in a clockwise direction. We've learned how to create hands, center objects. We've also created how to dynamically create objects. Otherwise, as I said, you'd have had to have object 1, then I'd have to have started object 2, counted around till 60 or 61, and then I'd have to have assigned numbers to these as well. Because these are the only the only 3 objects that need updating, these are the only objects we've actually assigned names to. So you've got hand.sec, you've got hand.min and hand.hour. And of course we've got the time up there to compare the hands being moved with. So it just hit 50 and it's carrying on quite happily. We've worked out how to add a gradient to the hour hand between these 2 points as well. And that's it. You've basically got your first real-time 3D clock. So now of course we're going to move on to the next section and we're going to add the perspective mode to it. In order to add our perspective commands, we now need to add a couple of new functions. And these functions will go directly into the main do and loop. And basically these functions are called set perspective mode, perspective, so we're going to pass a variable perspective into it, which I'll create in a moment, and update view, and this will basically update the view with real-time information such as whether or not we're turning the camera left, right, up, down, or zooming in and out, or simply increasing the height or decreasing the height. And because we're going to base this around the perspective variable, perspective will basically set the mode. So I'll just type in perspective here. So perspective equals set perspective mode, and we're passing perspective into it. And we're basically going to do exactly the same thing for perspective here. So basically these 2 functions can pass the value perspective back into perspective, and because we're doing this we also want to make perspective global, so obviously these functions can update it. So we're going to set perspective as global, and you'll see why I'm doing this as we'll go through it. So set perspective as global. I'm also going to set it as a byte because I know it won't go over a certain range. And we also need a couple of other functions. Sorry, we also need a couple of other globals in order to make this work. We need to global angle as a float. We need to global distance as an integer. And we need to global height as an integer. So basically, as angle increases, the camera will rotate around the central point. Distance, of course, will be the distance from the central point to the clock. By central point, I mean the sphere in the middle. And finally, height will obviously define how high above the clock face we actually are. We also need to set perspective mode to 0, and I'll show you why in a moment. So I'm just going to make sure I've got the right spellings and all these. It's a good idea if you know you're going to be using over and over to actually copy and paste over the top. That way, if there's any spelling mistakes, you've basically gotten rid of them all. So because I'm talking and typing at the same time, I'm rather prone to make spelling mistakes and not notice it. So now we know that that's all correct and the spelling is set up. It's time to actually create the the functions in question. So once again we're going to go over to the functions list, and we've got everything we've already created, so we just carry on from where we were. So now we're in the functions source code. I'm going to collapse all of these so I'll be able to keep an eye on what I'm doing more effectively. So we'll fold all these and we'll write functions afterwards, and these will be the additional functions I add. Before I get started, I'm going to create a function we haven't actually listed, and this is called normal view. And what this function will basically do is return us to our default look mode. So anytime I want to stop perspective mode from being perspective mode and reset the scene to the state it was when we first ran the program, I will be able to run this function. So these are very short functions, so we'll do that first. So function normal mode, end function, and we want to return 0 on this because anytime we call normal mode, if we set perspective mode to equal normal mode, it will return the variable 0, and that way perspective will be set to 0 itself. So 0 is going to indicate normal mode. So that's the top-down view we get when we start. Position camera 0, 240, 0. As you recall, this is what we set up in our clock face code originally. So position camera and point object camera. I'm going to do a little bit of cheating here. I know the center object is 1 because I set it up that way to always be 1, so I don't actually have to find out what it is. Though what I should have done really was create a variable called clock center or something like that, and that way I could have just referred to it by name, but for the purposes of this we don't actually need to do that. So set object position x 1, object position y. So I shouldn't really be doing this, because if I ever change that center object and put something else in front of it, then the camera will now actually look at the first object we've created and not the center of it. So object position z. Of course, when I originally wrote the program I didn't realize I'd be creating perspective mode, so it's quite natural to go back and fix variables in later. So in fact, rather than being lazy, we will actually call it something. We'll call it center, and we'll change these to center as well. So now it'll all point to center. So if I do decide to create an object later on, and I do it before this one, then I won't mess up the entire program in doing it. And of course, because center is taking place inside a function, creating it here will actually create it as a local. So we actually need to go back into the main source code and set that up as a global. So I'll do that now. So global center as integer, and that way global will ensure that the function can read and write to that variable. I could even do it so before clock face is set, I could set up the variable ID there and pass it through to clock and do it that way. Of course, it's always a good idea to check that the changes you made actually don't break the program. So I'll quickly run the program again to make sure that my setting it as global is working as it should. So that's all right now. So this sphere now is now referred to as center rather than just object 1. So I've given it a name so it has more meaning. We'll go back to functions and I'll collapse this one down here. We've made our changes, so I don't need that one anymore. Go back to normal, and of course we can change all these to center now as well. So this basically ensures, as I say, that we've got a logical name for the object in question, and that name will be referred to correctly, and because it's set up as a global, I don't actually need to pass it into the function as a variable itself. So now we set up normal mode. So every time this function is called now, it will reset the display to show what we get when we initially run the program. So of course the next thing we really need to do is set up the perspective mode. So set perspective mode, and of course we're going to pass a variable perspective into it. And of course, because global is set to perspective as well, we don't actually need to pass it back out, but it's good practice anyway, just in case you forgot to global something. Now I want to take in data from the keyboard, and of course I'm going to use a key state command, because this means I don't have to worry about cap locks. So I can assign you know, I don't have to create a key state, sorry, I don't have to create in key and then write the command twice with both a capital P and a little p. There is a little trick I've learned with key state commands, and that's to set up a set of constants at the beginning of the program. So we can actually refer to the key state variables, or rather we can actually refer to the key state constants we set up as logical names, rather than having to remember W is 17 and A is 30, etc. So if I now go back to my main source code window, then we can actually create a set of constants to give, as I say, our keys logical names. So we're here now, and put the constants at the beginning of the program, as it should be. And we're going to start off, I've already pre-planned my keys and what they're going to do. So I've got the minus and plus key will raise and lower the height. So I'm going to start off with them. So constant minus key. And as I say, you don't need to use equals with this. You don't need to set up what type of constant it is. It will just hold data. So we can set that up as 12. So anytime I call minus key, it will know minus key is 12. And we could do the same thing for plus key. So constant plus key. And as you can see, they now have logical names that actually make sense. So you don't have to try and remember all these numbers. And I've obviously looked up these numbers to begin with. So constant P key, which will be the perspective mode we're going to trigger. That's key number 25. Constant, in fact I'll just copy that because we're going to be typing it in rather a lot. So copy it to the clipboard and go to end. Then I'm going to set up N key as 49, constant Q key as 16, constant W key as 17, constant E key as 18 because it's next to W, constant A key We're going to set that up as 30, so we should know these ones. S key is 31 and D key is 32. So as I say, now we can grab the information on the key and refer to them in nice logical names. So now when I type in if key state, I can actually refer to the key properly. So if key state P key equals 1, then perspective, then perspective equals 1. And if key state N key for normal equals 1, then perspective equals 2. And you'll see why it's referred to as 2 in a moment. So again, I'm going to make sure that these perspectives are spelt spelt correctly. So, whoops, paste over that, paste over that, and a paste over the last one, and that way I haven't made any mistakes. So of course now we've created that, we can actually set the mode that the program is going to operate in. So we can close that down now, go back to the main source code and make sure we need to re-enable these commands, otherwise they won't work. And I need to go back into functions, and now I need to create the update view function. So function update view, we're going to pass perspective into it. So you don't need to do that because it's global, but I do it to make absolutely certain. Again, I'm going to pass it back into the program. So there we go. And now we're going to, rather than use the if statement, I'm actually going to create a case statement, which we should be familiar with from previous tutorials. So select the variable you're going to use, which is perspective, and we need to end select. And of course our case statements actually go between these 2 points. So I'm going to create case 1, end case, case 2, end case, and a case 3, end case, and of course I'm going to set case default, but I'm going to put a little bit of debug in here. So if perspective falls out of the 0 to 3 range I've assigned, then it will tell me what's going on, and there's a little bit of useful troubleshooting information. So text 40 comma 10 comma went fairly down the screen, so 100, and perspective out of range. So again, if we don't get 0, 1, 2 or 3, then it will tell me it's gone out of range. I also need to set case 0, of course. So case 0, end case. Now I don't want anything to occur if case 0 is true at all. So we're basically, it's going to trigger the case statement, but it won't actually do anything with it. The first case we're going to create is going to set up our camera and position it. So if you have a look at the previous function, if the P key is pressed, then perspective will equal 1. So as soon as you hit P on the keyboard, it will trigger the case 1 statement. So as I say, this is the initial setup data for our program, and I'm now going to type in position camera, and I'm going to place it in the center of the program. So 0, 0, 0, 0. So camera 0, which is default camera set up for any 3D scene, and I'm going to place it at coordinates 0, 0, 0. I'm going to set up the distance then. Remember, distance is global, so I don't need to pass it back into the program. So I'm going to set the distance at 200. I'm going to set the height to equal 75. I'm going to set the angle to equal 0, and I'm going to trigger the next case. So I'm going to trigger the case 3 perspective by typing in perspective equals 3. So once all this initial setup data and positioning has been done, it will then trigger case 3, because obviously we don't need this setup all the time, it's only a one-off. So and if case 2 is triggered, so if we go to this again, you'll see if we press the N key, then perspective equals 2. So every time you hit the N key, it's going to reset the camera, and we're going to do that by calling perspective equals normal mode. So as soon as we hit N on the keyboard, it will reset the camera, disable the perspective mode, and wait until P is pressed, or just continue doing nothing. Case 3, this is where we're actually going to take in user input from the user of the program. We're actually going to create a perspective mode using the data we get from that. So we're going to set up we're going to use a set of key statements, if statements. So if left key or key state A key, this basically means we can press the left arrow key or press the A key. So we've used the OR Boolean function there. We've got two options. So you can use the standard WASD as well as the arrow keys. Equal 1, then inc angle, comma, and I actually set it up as a float, if you recall. So we only want to increase the angle by 0.2. And now we need to set up the alternative. So if right key or key state D key equals 1, then dec angle 0.2. So that will then decrease the angle by 0.2. And obviously if you want a greater or quicker rotation around the clock face, you can increase these to 2.4 or 2.5, whatever you like. So next we're going to limit angle so it can't go above 360 degrees. So angle equals wrap value angle, and that will basically ensure that the angle will fit the correct range. Now we need to increase or decrease the height of the camera. So if key state plus key equals 1, then we basically want to increase the height. So inc height, comma 2. So we're now going to increase the height of the camera by 2 units. And if key state minus key equals 1, then dec height by the same amount. So next we need to control the zoom in and out of it, and we're going to use the up and down key for that, as well as W and S. So if up key or key state W key equals 1, then dec distance by 2, because we want to decrease it in order to zoom in. And if down key or key state S key equals 1, then inc distance by 2. So that will then increase the distance from the center of the camera. And now I'm also going to create another function to keep it nice and tidy. Perspective mode, and we're going to pass along angle, distance and height, and this will basically provide the screen with real-time updates. While I could keep all the code inside this function, I prefer to keep it separate, because if I need to tweak that specific code itself, I can then just edit perspective mode rather than having to go through a block of code in these case statements. So I'll try to keep them as modular and small as possible. It also means I can port it over to other programs that may work in a different way. So function, perspective mode, and we want to pass the variables angle, distance and height into it. Obviously end function, there's no variable we need to pass back. And now I'm going to introduce you to a new command called set camera to follow. And this is a very useful command actually. It's great if you, it's especially useful if you want to create the Tomb Raider style viewpoint, that is a third person perspective viewpoint. The camera will literally fix on an object and then adjust its settings based on the object's orientation, your settings, and as I say, it's a very useful command, and I'll show you how to use it now. So basically we want it to set, we want to set it to follow the center of our clock. I could set it to follow the hands, our hand, the second hand, or whatever, but I want it to focus on the center of the clock. And this is a very cheap way of creating an orbit, a piece of orbit code that allows the camera 360 degrees in all axes around the center of the point without having to get into complex cosine math. And all that stuff. So we're going to set the camera to follow, and we're going to set it to the center object. So object position X, and we're going to set it to center, and we're going to do the same with Y and Z. So object position Y, center, and object position Z. Again, we're going to get it to focus on center. And now we're going to type in the data we've just taken into account. So the angle of the camera in relation to the center of the object, the distance from the center of the object, and the height from the center of the object. And these next couple of parameters set the smoothness of the camera movement. So if we set it to 50, then it will basically create a nice smooth movement around the camera. The higher you make this, then the smoother it will be, and the more time it takes for the camera to settle. So if I turn a camera now with it set to 50, you'll notice that the camera will drift a little bit after you've taken your hand off the key. That's because the value set is actually slightly higher than when you took your than the display currently shows. So for instance, if you have a 0 to 10 range and you take your finger off at point 10, then the camera will likely only be at sort of point 7 or 8, and it will then drift up to point 10, creating a very smooth movement. So the final flag is to select collision. You can set it up so if the camera hits another object, then it won't go through the object. Again, that's very useful for third-person style games in the Tomb Raider vein, because it means if the camera hits a wall, it won't simply pass through the wall, but instead it will just, bounce off the wall or sort of drag along the wall, or however you set it up. So I'm going to set that to 0 because we don't need to worry about collision. The only problem with this command is it doesn't automatically tell the camera to keep angled on the object. It will only control the angle from it and distance and all that stuff. So we do need to type in the point camera at the object command as well. So this will ensure it's always pointing at center. So point camera at object position X, center, object position Y, center, and object position Z at center as well. So this will ensure that the camera is constantly focused on the central sphere in the middle of the clock. And that's basically it. We've now added in the perspective mode. So we've got the variable perspective controlling everything, and we've got various functions updating that variable, and that variable ultimately simply triggers these case statements. So as soon as you press the P key, it then sets the perspective mode to 1, which triggers a case which sets up the initial data, which then sets it to case 3, and until you press N and set it to case 2, which resets the camera data, it will just continue running case 3 and updating the variables here and passing them on to the perspective mode, which of course triggers the final function, which allows us to control the camera. So now the only thing we have left to do is to run the program and make sure it works. And as you can see, we have a fully working clock in normal mode, and if I press P on the keyboard, we have a fully working 3D perspective clock. Adjust the height as well. So we got height movement on the plus and minus keys. We've got movement around the clock face to the left and right. We can zoom in and out. Sorry, this is out and in. And you can do the same thing on the WASI keys as well. So, using all the lessons we've been through this tutorial series, we've effectively created our first fully 3D interactive program.